Hello, 7th graders. Your video for the last section of Chapter 9 is on simulating compound events. So the last time we talked about compound events, we discussed the fact that a compound event was more than one event happening. You wanted more than one thing to happen. Compound. Simulation is a model used to estimate the probability of an event. We talked about simulations a couple days ago, where you had to come up with your own simulation, like drawing cubes out of a bag or flipping a coin, whatever it might have been. You're going to do the same thing with this, but it's going to be a little more complicated. Each trial, the trial is just each time something occurs. Each time you flip the coin, each time you pick a card out of the deck, each time you draw a cube. So for our example here, 1/4 of a deer in the population has a certain disease. Design a simulation for estimating the probability that a scientist will need to test no more than 3 deer before finding one with the disease. So you can use whatever kind of simulation you want, but it has to make sense. Okay? You can't just say I'm going to flip a coin, and a coin wouldn't work in this situation because you're talking about no more than 3 deer. So you have to be able to, you could possibly use a coin if you did enough trials, but the one I have here, and this isn't the only answer that there could be, obviously, because you can come up with your own as long as it makes sense. Here's one that I have. I would put 1 red and 3 yellow cubes in a bag. The red cube is the diseased deer. For each trial, I'm going to draw and replace. The key there is I'm going to replace the cube each time I draw it. I'm going to keep track of the number of draws it takes to draw a red cube. The number of trials with 3 or fewer draws divided by the total number of trials gives an estimate of the probability that a scientist will need to test no more than 3 deer before finding one with the disease. That's my simulation. So I'm going to put 4 cubes in a bag. 1 of them is red, 3 is yellow. And I'm just going to keep drawing till I draw a yellow one. And I'm going to keep track how many times did it take me to draw a red one. Right? However many it took me out of the total number of trials I did, that's the probability that it's going to take no more than 3 deer before I find one with the disease. Are there other ways you can do it? Yes, there definitely are. Here's another example. In the U.S., 42% of blood donors have type A blood. Use the random numbers below as a tool to estimate the probability that it will take at least 4 donors to find one with type A blood. At least 4. So here I just have a bunch of random numbers. Okay? And look back at the question. How can we use those numbers to do an estimate? There's low numbers, there's high numbers, there's numbers in the middle. So let's just say that we decided that type A blood was anywhere from 0 to 41. So if I go through each one of these rows and figure out where, since it says that it will take at least 4, where did it take at least 4 before I got a number that was 0 to 41? This one only took 2. Whoops, I don't know what I just did there. That one only took 2 tries, right? The second person, right there. This one doesn't have any in there, right? This one had one on the 3rd try. This one had one on the 2nd and the 4th. The 2nd, the 3rd, the 1st, and the 4th. The 3rd, the 3rd, the 2nd, the 1st, and the 3rd. Estimate the probability that it will take at least 4. At least 4. Okay? You can see here that all of these other ones, before they got to the 4th person, they had a type A donor, right? This was the only one right here that did not have a donor in 4 tries. So you have a I don't know what's going on with my pen here. You have a 1 in 10 chance, correct? Well, it's not going to let me write 1 in 10, so we'll just pretend that I did. So right here, I have a 1 in 10 chance when the numbers 0 to 41 are used to represent a donor with type A blood. A 1 in 10 shot that it's going to take at least 4. You can see there that usually it was before that. It didn't even take 4. So, simulations, there isn't necessarily just one answer for these. That's the bad thing. That's good and bad. It allows you to be creative. So, bring that knowledge with you. Talk about it more next time I see you. Have a